Okay, Mr. Diwali, you are welcome. All right, so we are live already, and yeah, just a minute. Yeah, we are actually live already.
Okay.
So you can actually upload your slide if you have a slide, or you want to actually do screen sharing. You will
Okay,
see
I'll do.
present at
Yeah,
the
let me do screen
at the
sharing.
middle
Yeah, so I can
of
see
the
that.
screen.
Let me do screen sharing.
Okay, I don't know if you can see present. So from present, you can then choose to actually uh, share screen or actually upload your slide.
Can you see my screen now?
Oh, okay.
Yeah, the music
When
is
it is
still
actually
on.
time, yeah. So when it is actually time, I can see it now.
Yeah, the
Uh,
music is still
it's
playing. Can you turn it off?
yes, yeah. The music is yeah. I know.
Oh, good.
Okay, so yeah. It seems that your slide is not actually showing very well. I don't know. Okay.
Yeah.
You can put it on slideshow. You can put it on slideshow. Uh, okay. While we are waiting for you, we just do a little bit of some introduction,
Mm-hmm.
and then we would have you on the stage. So welcome, guys. Apologies that we actually started some bits late. Yeah, but we are very excited to actually welcome Mr. Diwali Adegoke. He's actually a senior professional in the geospatial industry with vast years of experience when it comes to leveraging GIS in agriculture for diverse use cases and even beyond investment, land management, and all that. So he's going to be taking us through a class today on geospatial uh, survey and mapping also. So, of course, in the context of precision agriculture. So before that, I am going to bring on Joseph to quickly talk about Precision Feed Academy, what we do, who we are, and yeah, and we move forward from that as short as possible. Thank you so much, Joseph. The floor is yours.
Okay. Uh, Good morning, everyone. Uh, Happy New Week. So glad to be here again. As we move forward, today we are going to be talking about geospatial survey and mapping operations. And before we do that, so I'm going to quickly do a slight introduction about Precision Food Academy. So at Precision Food Academy, our vision is to create a world where every young person, regardless of their background, has the opportunity to become a digitally savvy farmer or agricultural professional, driving sustainable and equitable growth in their communities through the transformative power of technology. And our mission is to raise the next gen farmers that are tech inclined and digitally savvy. So about Precision Feed Academy, we are a social enterprise. We train and build the capacity of young professionals in modern and emerging technologies for the future of work and to lead with precision agriculture. So we believe in core methodology, which is education and knowledge sharing, training and skill development, coaching and mentorship. And besides this, we have test skill in focus, which are drone technology. So we are leveraging the power of drone technology to transform and change the paradigm of agriculture, to redefine the way agriculture is being practiced in terms of how you monitor your pests, how you monitor the health of your crop, of understanding how your crop feel to actually give them the best response or treatment. So also we have GIS and remote sensing. This is about collection of data from the space through the head of satellites and also using drones for remote sensing or collection of data. So we have data science in agriculture. It's talking about plant classification, the integrate part of the data about plants and how you do your evaluation and analysis. It's about data science in agriculture. We have robotics and Internet of Things. It's more like expert systems that can actually work instead of human. For instance, we could have like a smart irrigation systems that can actually trigger your drip irrigations on the farm in response to the soil moisture level and all of that. So embedded system, Internet of Things, and robotics actually work hand in hand, and this is part of what are serving as technology in digital agriculture. We have artificial intelligence and machine learning. In case where you have a very large expanse of land, like you have a plantation, maybe a maize plantation or a variety of crops like that, and you actually want to note the disparity between these plants. Probably in case of mixed cropping, you have beans, you have maize. With artificial intelligence algorithm, with drone enabled sensors, you can actually dictate these plants individually and also do the estimation or to actually calculate their numerous numbers through the head of AI and machine learning algorithm. And lastly, we have enterprise development. So the goal of all the training here is for youth to actually end up creating a sustainable enterprise that is focused at solving problem, bringing up new innovations in terms of precise development of product that can actually help agriculture practice to become optimal and efficient. So why do we do what we do? Um, Basically, these are motivation. There is a skill gap that needs to be closed, and young professionals need to build skills on both technical and enterprise skills for the future of work in agriculture. This is talking about young professionals need to be included in building capacity skills on both technical and enterprise skill. So observing the trend is not enough. So youth need to become an enabler and player of what agricultural revolution and not mere observer. So youth need to demonstrate this capacity, they are resilient, and also be included in bringing up new innovations, facilitating new technologies that can actually help agriculture to become much more better and efficient. So also thirdly, technology is the key to unlock African agriculture potential. So African agriculture, for us to actually change the game, we must leverage the power of technology to actually transform the way we practice agriculture. So why should you join us? We are creating a future we want in agriculture. We also connect you to the world of information, which comes in terms of opportunity, scholarship, internship, volunteership, programs on both local and international level for your career growth. And also, we promote skill development, skill enhancement through project collaboration, community interaction, workshops, and symposiums. And lastly, you have access to coaching and mentorship from industry leaders and professionals. So at Precision Field Academy, we are building a community of young tech inclined and digitally savvy farmers and professionals. Thank you.
All right. Thank you so much, Joseph. Again, our mission, our goal is to actually have a community of agricultural professionals and farmers who are tech inclined and who can leverage the power of digital technology to bring transformation in the agricultural sector, providing us with food security, making creating a better livelihood and a better society, more resilient society. So, without further ado, I would like to actually welcome Mr. Adewale Adegoke. Mr. Adewale Adegoke is actually uh, the managing director of Nigerian Flying Lab. Flying Lab is part of the global network of the Flying Lab Global Network, and he's also the CEO of Agro Exchange, an agri-tech startup here in Nigeria. So I'll be bringing up a slide. Without further ado, Tadewale, the floor is yours, sir. Thank you so much.
Thank you very much, Femi. And I welcome all of you to this introductory training on, to GIS and mapping. And basically, I would implore that we make this interactive. so it doesn't appear like I'm speaking to myself. You get what I mean? So you can stop me at any time to ask questions, and I would ask you questions also as we proceed on the training. And because if we're doing a physical classroom, then I'll be able to see you, monitor your body language, and basically be able to engage you actively, right? But we're online, so I can't see you, and so I'll ask you to stop me at any time to ask questions, make comments, right? And so it can be more interactive and more engaging for all of us. Because I'm sure most of us have some understanding of GIS and mapping, and some of us don't. So this is basically to introduce the GIS and mapping, what GIS is all about, and how we can apply that, to make ourselves financially independent, especially in the agricultural sector. And as been introduced earlier, my background is geographic information systems. I've taken some other courses in finance and leadership, because starting a business includes finance leadership, for you to be able to understand what it means to be a leader, what it means to be able to manage a business in terms of finance. If you're raising finance, if you're managing your finance, it's critical. And I went further basically to put all of this together. And as you know, a question that I always ask myself is, what is the key relevance of geography, in the scope of things, especially in the economy? Why do we need geography? Of what use is it, And if we look back, and we look at macroeconomic theories, especially in terms of, factors of production, a key factor of production is land. You get what I mean? How do you manage land effectively, right? To be able to produce. And what what we're experiencing in Nigeria right now in terms of inflation, that keeps increasing. I think as at yesterday, inflation is about 31.7%, which has increased, since from 30% or 29.9%. So how do we basically integrate GIS into this? How do we make GIS relevant, to our socioeconomic status? How do we make GIS relevant to our economy, both at the micro level and at the macro level? We have to look at things like this, And so we're going to go through the following. There are a lot of slides, but some of them are just that pictures, which are self-explanatory. The others I'm going to explain with examples, practical examples, right? So we have introduction to GIS, what GIS is all about, software options, applications, understanding maps and data layers, spatial data types, characteristics of spatial data, metadata, and making maps. So basically, all of this has to do with from conceptualizing your idea, right, to presenting your idea, or conceptualizing, collecting data, processing the data, and presenting it a way to be able to act as a decision support system, right? Now, the definition of there are different definitions of geographic information system, right? And we need to look at the operative words here. So we have geographic, we have information, and we have a system, right? So let's take it from the back. A system, which is, as you can see, a system for capturing, storing, checking, integrating, manipulating, analyzing, and displaying data. Just like I mentioned earlier, is for you to be able to conceptualize, collect the data, right? So that when you're conceptualizing, you are designing. You are designing how the data will be presented. What you need to do. Sometimes you have to work from bottom up, not top down. You get what I mean? So you need to have a vision, what you want to do. What are the key, let's use a project, for example. What is the scope of the project? What do you need to do to achieve the desired objectives, or the desired outcomes for that project? So here you have a system that captures, you have to collect the data, you need to store it somewhere, You need to check it. You need to quality assure it. You need to integrate it, right? Or you need to process the data, analyze it, manipulate it, and display the spatial data as a result. It's result oriented. You need to be able to check it so that you know that, okay, look, hey, I'm presenting information that will be able to change a situation. You get what I mean? So this is why it's a system. You get what I mean? And it's geographic. It uses geographic primitives. It uses geographic data information. So it has to do with anything observing the earth. You get what I mean? And I'm sure you guys have heard about the phrase earth observation. You need to observe the earth. You want to check location of farms. You want to check what is happening on the farm. You get what I mean? You want to check if there's a group of farmers, that have peculiar problems. How do we resolve that problems? How are they spread apart? A good example of this is traceability. Traceability in cocoa value chain, right? Traceability in maize value chain, in cassava value chain. Mostly right now there's more focus on traceability in cocoa value chain, which my company is actively involved in Osun, Ekiti, Ondo, and Cross River states. So that is what you need to think about. How do you collect? What sort of data are we talking about here? That you want to collect, that you want to analyze, right, to be able to make this informed decision. So a system, for spatial data. So we have to look at the system, right, and spatial data. So the input is spatial data. Like I said, you're observing the earth. You want to know features, because if you look at the primary or the basic definition of geography, is the study of features on the earth's surface, right? Earth has to do with geography. You get what I mean? Land. You get what I mean? Because if you look at the entire earth, everything has land and water. You get what I mean? Even under the water, you still have land. You get what I mean? Where you have to do with bathymetry, the topography of, seabed. You get what I mean? Or waterbed. You get what I mean? Or riverbed, as the case may be, land. And that was why I used land initially in terms of the concept of production, factors of production. So you have to look at it from there, because when you're collecting geospatial data, it has to do with spatial. It has to do with space. You're collecting it somewhere. That place you're collecting it is a plot of land. You get what I mean? Owned or not owned by an individual, but basically is owned by government. You get what I mean? So because individuals collect land from government, according to the Land Use Act. So in Nigeria, though, so we look at the spatial data, which is the input. That is what what goes into the process. Now, the spatial data basically goes into the mapping software so that you can visualize it, you can analyze the data. That is what you call visual assessment. You want to see. Let me give you an example. We currently, so let me go use the example of the cocoa value chain again, where you have different maps, owned, showing different farms owned by different, individuals, different farmers, what they're growing. You get what I mean? How much they have spent, on inputs, how much they spent on, on basically maintaining that farm. You get what I mean? You want to know what is going on to be able to make, informed decisions about traceability. I want to know where this bag of cocoa has come from. Who has it come from? You get what I mean? So you visualize the data because you need to be able to see, right? And the output is new data and maps. Now, what is the key output of any GIS system, right? Is a map. Are you getting me? Now, the key outcome is planning, because you are using it to plan, right? It could be urban planning, it could be traceability planning, it could be any, even fiscal planning. You get what I mean? Because CBN uses geospatial data, right, for planning disbursement of credit under the Anchor Umbrella scheme. You're right, to farmers. They used geospatial data. My company was actively involved in that as well. So it's planning. Because if you don't have visual assessment, how do you plan? How do you make informed decisions? You're going to be losing money because you're spending money as a business. You're going to be losing money if you don't see what you want to do, and also you'll not be able to manage your resources effectively, right? So in terms of theoretical overview, GIS basically creates a representation of real world data. So you have the real world, but you need to be able to present it as such that, anybody can see it, and understand that it's like a model. You get what I mean? And you have stacks of layers of data. As you can see here, you have the real world, and you have the customer streets, parcels, elevation, land usage. If you combine all of this together, it'll be able to give you meaningful insight or actionable insight into the current problem that you are trying to solve. So for here, if you use this example, for example, so you say customers, let's say the customers are the cocoa farmers, right? The streets, right, are there, the parcels are there, the elevation, the land usage are there. So by the time you cut through these layers, you'll be able to get information about, okay, why are these cocoa farmers here? Are they based in areas where you have forest reserves? Exporting cocoa overseas has clear, how would I call it, clear regulations regarding the use of forest reserves for cultivation of crops, because we shouldn't be using forest reserves, you get me, to cultivate crops. But unfortunately, these things happen all over the place, right? So how do we know the farmers that fall within the forest reserves and farmers that do not fall within the forest reserves? You get what I mean? It affects the business for the off-taker to be able to export, because they want to see the maps of these farmers. You get what I mean? So now this can be assembled in any combination, not just like this. It depends on what you want. So you can move the land usage, to the top, or the customers to the bottom. It doesn't matter. You can do all of this in your GIS software. And before I continue, I want to find out if you guys have prior knowledge of GIS softwares. You can just unmute your mic and let me know if you have prior knowledge of any GIS software, be it proprietary or open source.
Yeah, listen, they may not be able to speak, but they will be able to use the comment section. So I'm looking at the comment section now, and I'll be projecting them on the screen for you to see what our students are actually commenting on. Okay. Yeah, guys, please make comments. Please comment on GIS softwares or the special application softwares that you are familiar with. Just mention them. Just mention them in the comment section. We want this to be
anyone that you're familiar with. You get what I mean? I mean, you'll be surprised that the ones that you're familiar with, I may not even be familiar with it. We want to learn from each other. So this is not me just dumping information to you. And I do not have, despite my years of experience in GIS, I do not have monopoly of the knowledge. You get what I mean? I like sharing, and I like adding value to what I already know as well. You get what I mean? So if whatever you know, please kindly share. Unfortunately, so I can't.
We have Antonio says she knows about QGIS, ArcGIS, Google Earth Engine. We also have another SDG farmer. Can you see the screen, sir? Can you see the screen?
No. Well, yeah, I can see. I had to go back to this thing, so I have to go back. So I can't see. That is why. But you can be telling me as we are presenting.
All right. So Kujus Ade also mentioned that he's familiar with Google Earth, ArcGIS, QGIS. And Sinead also mentioned that she's also familiar with QGIS, ArcGIS, and Google Earth Engine. I think we also have Google Maps. There are a lot of them. Google Maps is also a GIS platform. We also have the ArcGIS seed maps.
Okay,
Yeah,
that's great. That's great. Thanks everyone. It shows, you have some sort of introduction or some sort of relationship with this. However, we have different types. We have geo browser, we have web-based, we have desktop. So you see, the geo browser is what we all have, on our mobile phones. They give us information about distance, about location, about directions. But when it comes to analysis, they don't do that. You get what I mean? Because it's just for you, it's for visual assessment. Let me put it like that: visual assessment. I want to find out what is here. I want to go here. That kind of thing. That is what it does to you. But if you now say, okay, look, show me the areas that are going to be susceptible to flooding, they can't do that, right? They can't do that. You get what I mean? So because their powers is limited to certain, activities. The web-based, you have ArcGIS Online, Mapbox, Google My Maps, different stuff. I'll use ArcGIS Online, which I'm quite familiar with, for as an example. You have for ArcGIS Online, you can create web-based maps. I'll show you some after this. You can create web-based maps. You can create dashboards. You can create really good stuff that conveys information, insight, right? Insight into a problem. You get what I mean? And also puts it online so that you can share it. It is shareable. You get what I mean? You have to bear in mind, again, like, I said something. I said, despite my years of experience, right, I like to learn from you as well. So that means we're sharing information, we're sharing knowledge, you get, amongst ourselves. And that is the same way the web-based works. You get what I mean? If you can't share your data, your data will have very minimum value, right? And let me give you an example. If you look at public sector, I'm sure you've heard of the Lagos State GIS, Ondo State GIS, different GIS. A key problem with the GIS, around is lack of interoperability. You get what I mean? It has to be interoperable. You need to be able to share this data. So Ministry of Health should be able to share data with Ministry of Land. You get what I mean? They should be able to share data with Ministry of Environment. Let me give you a very good example. Last year to early this year, we did a project on flood vulnerability assessment, because I'd supported the government of St. Lucia for a couple of years on disaster vulnerability, on a disaster vulnerability project funded by the World Bank. And so we took that to Ondo State, on flood vulnerability assessment. I'll show you the web-based map as well. Now, I now noticed that when you are doing flood vulnerability assessment, right, the data, right, once you identify the households, the vulnerable households, or the households or businesses that will be susceptible to flooding during the rainy season, you also have to consider the people that will clear the gutters that has pure water, bottles and everything inside. That is Ministry of Works. You also have to consider Ministry of Health. You get what I mean? Because of mosquitoes. When water is stagnant, in the gutters, and also what does it, besides causing flood, right, because it's blocked, it also creates mosquitoes. That means people will have higher incidence of malaria and stuff like that. You can see the combination. So it's not just a system that works in silos, right? You need to be able to share the information or the data. Now, the desktop, which is strong, uses it to author data. That is where the sexy stuff happens. That is where everything happens before you even publish it on the web. Now, bear in mind, ArcGIS Online provides you, tools that will enable you to actually analyze the data online, which you'll be able to share with your partners, you'll be able to share, with other stakeholders. So, but for the desktop, that is where you prepare the map. That is where you prepare the data. That's where you offer it. That is where you make your definitions. That is where you do strong analysis. You get what I mean? Because of the processing power, right? You have to consider the processing power as well. That is why if you look at any desktop GIS, you see the software requirements there. They tell you how much processing power that is needed. You get what I mean? And all that. You get what, but you see the web is using back-end processing power, which you don't see, you don't have access to it because the servers are online, right? So there are minimal stuff that you can actually do in terms of the amount of data that will be able to run or process, that will give you quickly. So for instance, for desktop, if I'm using a 32 gig laptop, at our office, we use 32 gig laptops, you can do this quickly, with large amounts of data, but you may not be able to achieve the same result for the web-based and for the geo browser. So for this, try uploading data points of over 1 gig in Google Maps. You see what happens. You get what I mean? The performance will drop, right? So these are some of the things that you'll be able to do. So these are the differences. And with the desktop, you still have QGIS, which is free. You have ArcGIS Pro, which is proprietary. You have to pay for it. Sometimes we use a mix, so there's sometimes when I'm doing a geoprocessing, right, in ArcGIS Pro, and it crashes the system, right? We take it to QGIS and it gives us the data. Then we not take it, the output data, back to ArcGIS Pro. You get what I mean? To be able to generate our maps, right? So we use these are some of the experiences that you would have access to when you are doing things like this. Additionally to this, you also have map info. You get what I mean? Map info is not my personal favorite. You get what I mean? I've developed on ArcGIS. I started developing on ArcGIS, maybe like 15 years ago. I don't do technical stuff anymore. You get what I mean? I'm an entrepreneur right now, but I have really strong guys that do all of these things, and they've contributed immensely to the growth of our company. So you can basically go online to check comparison of ArcGIS Pro, QGIS, MapInfo, and all that. You get what I mean? So it depends on what you are able to latch onto and catch on with. You get what I mean? And the learning curve is all up to you. But I can guarantee you get almost the same result, from all of them in terms of presentation and all that. You get what I mean? So, but if you want to, in terms of cost, I'll say QGIS. You don't have to spend money on that, and you'll be able to get, all the stuff that you need, really. So so this is the comparison, we just software should you use today? Yeah, it's commercial. It's expensive to purchase, considering the exchange rate right now, you don't want to go there. You know what I mean? QGIS makes a lot of sense, and with Nigerian Flying Labs, we can work with, precision farmer to basically see how we can make the ArcGIS Pro kind of available for you. And also, you get what I mean? QGIS, you can just download it now. You get me? And, and do what you need to do. So, yeah. And we ArcGIS, because it's ESRI, Environmental System Research Institute, that global leaders in GIS. So you have MOOCs, but the MOOCs is massive open online, massive open online courses or so, yeah, that's basically what it is. So you can learn a lot of this. What you learn there, you can still take it and use it in QGIS. You get what I mean? Because it's telling you that, okay, this is the basic principle, so you can apply anywhere, And I'm saying this because, again, this is stuff that I've developed on, you get me, for a long time. You get what I mean? And I know, okay, look, hey, from personal favorite is ArcGIS. I use QGIS as well, so yeah. So that's basically what it is. Now, for applications, as we're going through this, I'll be using some local stuff. You get what I mean? So we can localize, our knowledge and our experience from this course. But one thing I want you guys to know, to have, is the basic premise of the training. Don't get hooked up on how fancy you want things to be, or your, the expectation. I want you to latch onto the basic premise, of the GIS, So in your mind, you start thinking, okay, can I use it for this? If I use it for this, how do I, what would be the result? What areas can I apply it? So for In terms of the GIS applications, we have, you can view imagery. For guys that are conversant with Google Earth or Google Maps, I'm sure, viewing imagery is something that you are quite comfortable with. You can create 3D models, you create 3D models from height values, you get what I mean? Because if something doesn't have height, right, that's the third dimension, you can't create 3D, you get what I mean? So you create 3D models from height values, and one of the things that you have, I'm sure if some of you know what we call digital terrain models or digital elevation models, they kind of work like satellite imagery, but not quite. Satellite imagery gives you a picture, but digital terrain models, which sometimes are derived from satellite imageries in stereo pairs, right, or from satellite, right, like shuttle radar topographic mission and all that, they will have height values. That is why they call it digital elevation. Elevation is height, they have height values. So buildings like you see here, they have height values. You get what I mean? So if you don't include the height value, then you won't get this. You will not be able to extrude it. Extruding, increasing the height, really. So there are 3D software that you could use as prescribed there: AutoCAD, Rhino, Photoscan, etc. However, ArcGIS Pro, has ArcScene that you can use to also create 3D models. You get what I mean? As we're talking again, I want you to start, you can go online, on Google, just, ArcScene. Scene means like scenery. You get what I mean? SCENE. Start thinking about stuff like that. You get what I mean? So then you can create maps. Here, as you can see, showing you ancestry, Irish roots, and stuff like that. So it combines art and science. Creating a map is actually an art. You could create a map that nobody understands, but you understand it. Are you getting me? You can create a map that nobody understands, but you understand it. But then again, you can create a map that is so easy for even a child will be able to see that, oh, I think I know what this stuff is talking about, right? So that is very critical. It all depends on how well you are able to, conceptualize, what you want to do, and basically push the boundaries of your imagination. So it's not something that has to do with, it has to be technical knowledge alone. No. You can conduct analysis, analyze values, spatial statistics, edit geometric tools. You get what I mean? Create buffer data. Now, I'm sure there's a National Bureau of Statistics. They have a web-based interface, and other bureaus of statistics in most African countries, they have web-based interface. World Bank has, where you can see what is going on in terms of demography, in terms of socioeconomic assessment, and all that, right? Buffer tools is for creating buffer radius. So for instance, if I say I want to know how many buildings fall within a kilometer radius or a kilometer radius of a particular area of assessment, I have to do buffer of 1 kilometer. You get what I mean? So I do buffer of 1 kilometer radius, 1 kilometer, right? So any building that now falls within the first 1 kilometer, I know, okay, these are the buildings I'm talking about. All of these are available as tools in ArcGIS, right? And for you to understand the data layers, what individual data layers, were used to create a map like this, you have to look at, so this from Google Maps, you have bodies of water, you have street network, you have points of interest, you have parks and open space. So these are some of the components of the, of what you need to understand the data layers. And if we go back, sorry, I'm going to be doing this, every now and then. These are the data layers that I spoke about, remember? So if you have, for this, right, if you look at these layers, this is what it translates to, actually. You get what I mean? But when you're looking at it, because it's 2D, you don't see those layers. Even in 3D, you don't see those layers. You get what I mean? So basically it puts everything together for you to be able to give you this level of visual assessment. Now, let's look at the geospatial data types. So we know basically what we're dealing with. To model the real world, we have two key data types. We have vector and we have raster. A vector has to do with, points, lines, polygons. So let's go back here. So can you see, if you follow my cursor, you can see the road network. Those are lines. You can see the road network. You can see the streets. Those are lines. Yeah. You can see the point of interest. That is a point. It's self-explanatory. That's a point. It can be, it is more often than not GPS, longitude and latitude, right? So you can see that. You get what I mean? So that basically is vector data, right? So if you go to Google Maps now and you turn on the satellite with street names or road names layer, the road names that it shows, those are vector. Are you getting me? Points, lines, and polygons. The boundary of a farm is a vector, because it has vertices that connect together to form one polygon. It could be a geometric polygon of a rectangle, it could be, they are funny stuff, you get what I mean? So yeah, that's it. And for raster data, it has row and column matrix. Raster data, so now vector data doesn't consume as much processing power on your computer. Do you understand? It's lightweight, it processes easily. But you see, raster data is heavyweight because every point, every cell is actually a data storage, and it is heavier. So your raster data, an example is just satellite imagery, here. This is your raster. So when you go to your Google Maps, the satellite imagery is raster. The road network overlaid on the satellite imagery is vector, right? So you can combine the two. More often than not, you combine the two, So yeah, so that's it, So you have these two. So it is these two that basically model the real world. You get what I mean? For you to be able to make informed decisions or gain insight into the problem, right? That you are trying to solve. If there's any question, please. Again, you can put it on. You can put it on your on the chat so that it can be read out to me. So vectors are composed of coordinates, vertices, like I mentioned. So you have your vector. So you can see these dark points, those are vertices or coordinates. You get what I mean? But rasters are composed of pixels, so each pixel, each cell has data, right? It has a number attached to it. You get what I mean? Now, let me give you an example of, earlier when your convener spoke about using data for crop monitoring, right? If you look at different indices, different indices that use NDVI, for example, normalized differential vegetation index, when it changes, right, you know that, okay, this stuff has changed value. That means your crop health, you get me, is probably compromised somewhere on the farm. But how do you know that? It is because of the changes that is being captured by the pixels in the raster data, which is the satellite imagery that you're using, that has been captured, that is now sending the information out to you, showing you that, hey, something has changed here. You get me? And you need to know that when, you see, let me explain something for you. So you see this image you're seeing is red, blue, and green, If you look at the electromagnetic spectrum, right? You have different bands of, different bands across the spectrum. So you have red, blue, and green. You have multispectral. You have hyperspectral. You get what I mean? Don't let me confuse you with that. But for agriculture, you normally use hyperspectral. You use all of them, basically, RGB, hyperspectral, multispectral, to be able to get information depending on the information that you are looking to get, right? and everything has to do with the capacity of the plant to be able to process, incoming solar radiation, right? And also to be able to reflect and how much of the incoming solar radiation is reflected. So that is what the raster will show you. You get what I mean? So as you say, these are often used for variables with defined borders, e.g., man-made, continuous surveys, e.g., environmental agriculture. So for vector examples, you have points. The points can be location of farms in points with your GPS, which you can download on your mobile phone. Lines, road network, fiber optics, hydrology, and all that. Then you now have the polygons, which often represent boundary of farms, boundary of administrative boundaries, you get me? And when you combine the two together, the three together, you now have the points, lines, and polygons on one. Again, you cannot use just one to make decision, because if you use only the point without the administrative boundary or without the polygons, how do you relate the point, in terms of distribution, in terms of relationship, right, to the polygon? So you'll not be able to do that. You get what I mean? You have to combine everything. Again, as you're combining the data or integrating it, conceptually on the software, you also have to look at that in real life. That's why I said these things are not done in silos. The data makes sense when it is combined, when it is integrated. You get what I mean? Because it is a system. Again, geographic information system. It is a system. So what affects the head, affects the arm, affects the leg. So everything has to work together to be able to make an informed decision. Let me stop there for a second. I'd like you guys to ask questions or make comments, as the case may be. So I'm waiting for that. Any question or comments from anyone? Hello? Is anybody there? Femi, are you there? Can you hear me, Femi? Hello, Femi, can you hear me? Hello? Femi, can you hear me? Can you hear me, Femi? I can't hear you. I can't hear you. Can you hear me? Can you hear me? Okay, right. Yeah. So you can take off your mic, or mute yourself to speak, because I can't see the chat. Yeah. Is there any questions from anybody, please?
Can you hear me, sir?
Yes, I can hear you now.
Can you hear me?
Yes, I can hear you now.
Yes.
Is there any questions?
Yes, I can hear you. I'm not
so
sure
far
if you can hear me.
from the participants? Any questions?
Yes,
Any
I can hear
areas
you, sir.
of confusion? Any areas of confusion? Any concerns? Any comments?
Yes, I can hear you, sir.
All right, cool. Any questions from the participants? Any areas of concern or any comments?
Yes.
Okay. What question, comments, concerns? What is it, please? Okay. I think I will carry on. So I will assume you guys have been following me and you have a really good understanding of what I'm talking about. So
I guess we are still. Yes. Okay. So all right. So so far, we have no question yet.
Okay. All right. Cool.
Yes.
I'll carry on.
Yes.
I'll carry on.
Yes. So far, we do not actually have questions,
Have any questions?
but
Okay.
yeah, but oh, okay. Okay, so I think a question here would be, you mentioned bathymetry, if you can hear me.
Yes. Yes, I can hear you. I can hear you.
Yeah.
I know in Nigeria you have issues with the internet, so that's understandable. I'm here for you, so just let me know. Take your time. You can type it. You can type in the chat section. Um, if you want to know stuff about, hello, hello, are you there? I seem to have lost you. Hello. All right, yeah. Okay, guys. I'll carry on from here. So you have the basic premise of the data types. So for vector mapping, your front-end geometry, so you can map the administrative boundaries like local government areas, wards, districts, all of that. You can map farm boundaries. You get what I mean? So it's like I said, it's got to do either your point, line, or polygon. And so for the backend database, because when you map this, when you do the mapping, it has you have to put data somewhere. So if we go back to the definition of GIS, where it mentions of the system capturing, storing, right? Capturing, storing. So if we go back and we look at, this is where the data about this administrative boundary is stored. Because if you just look at this, you don't really know what it is until you now come here, So you'll now be able to tell you that, oh, this is Ondo State, this is Ogun State, this is the population of Ogun State. You get what I mean? All of that information. So that's basically what it is. So in your GIS, when you right click, you say open attribute table, and boom, it gives you all this information. You get what I mean? So you now be able to see what is going on, as the case may be. Now the file format, the shapefile is the most common proprietary proprietary file type. You get what I mean? And it has 5 key extensions. So you have the shape, SHP, you have SHX, you have SBX, you have DBF, you have PRJ. The SHP is the shapefile. This is the shape, where you can see shape, the geometry. So when you click on this, it just takes you straight to your GIS, and it opens the map on your GIS. The database file is what you actually have in your database here. This is the database file. Once you delete the database file, the shapefile is not going to open. All of them must be together. Then the PRJ is the projection. Projection is how you wait, let me see. Okay, my video is on. Okay, so let's imagine a globe. Yeah, a globe like this. So this is our globe, right? I'm trying to see what, so this is our globe, a globe, how the earth is. But now you now want to put that earth like this, right? You don't want to put like this. You need projection, right? And the projection will now translate into the orientation, either here or here, right? And also the location, right? Every place on the Earth surface, they have different projections. In Nigeria, we use geographic and projected. Other areas too, they use geographic and projected. In Nigeria, we use commonly UTM and WGZ for which is geographic. If you go to your Google Maps, it's mostly geographic, right? But if you are doing stuff with like Office of the Survey General, survey plans for land, when you look at the survey plan, you see, the projection there, they put it UTM, it could be, WGS 84, 32 degrees north, or MENA. You get me? 32, 31 degrees north. You get what I mean? That is what basically enables you to be able to position that data, exactly its position on the Earth surface, So for the raster, remember, I mentioned the satellite image, I mentioned, digital elevation models, another one I did not mention is scanned maps. So, if you can scan your survey plan, so you can georeference it. Georeferencing means you want to put it, that survey plan that is in paper format, right? You want to put it on your GIS so that you can now put that survey plan on the area where it falls in, on the local government area or the ward or this, so you can know basically the exact location of that survey plan. You cannot do that again without using other data layers, because if you just scan the survey plan and you georeference it, and there's nothing underneath defining the relative location of that survey plan on the Earth surface, then you don't really know where it is, right? It's of no use. So you have to combine it, either with satellite image or your DM. The satellite image shows you a picture of what you can see on the Earth surface, like what everybody knows, Google Maps, Google Earth. The digital elevation model, you can see, is extruded, like 3D, right? It has height values. So it tells you. So if you go to Google Earth and you go to, I think it's topography, or I can't remember now, wait, hang on. 1 second. If anybody has Google Earth, you can just check it out now, right? So you have, if you go to the layers on Google Earth, so you have terrain. Yeah, that's what it's called, terrain. So the terrain basically shows you, it shows you, how the Earth, is basically how it is in terms of undulating, heights and stuff like that. So you have areas with high values, which are like hills, mountains, So what you can see here, these are like mountain ranges, these mountain ranges. Then here, that valleys, you get what I mean, and stuff like that. From the DM or digital elevation models, you can also derive drainage source in terms of water. You can also use it to be able to show how water moves in terms of hydrological or hydraulic analysis, which is critical for agriculture. So you have raster mapping, each cell has its own value. A raster can only symbolize one variable at a time. You get what I mean? It cannot symbolize two variables, just one variable, at a time. Then you now have your DM, you get what I mean, which basically shows you can see that this here is different from this here. So, and you see these lines here, these are drainage systems. You get what I mean? This is almost looking like a watershed. You get what I mean? These are drainage systems, right? Now, the whole point of using all of this basically, is for you to be able to understand and imagine how you can use it for agriculture. Agriculture needs water. There's no agriculture that doesn't need water. How do you know if the land you are getting, or you are consulting for a client that wants to do agriculture and he's saying, hey, have 30,000 hectares and I want to know if this place is going to be viable for oil palm? What do? You need to identify the water sources. You need to identify if they're perennial, if they're non-perennial water sources. You need to identify if these water sources, if they're high intensity rainfall, there's going to be a flood, which means if there's going to be high intensity rainfall, if there's going to be a flood, that area is going to be flooded. That means he's going to lose his investment. You need to be able to identify that so that he has some level of pre-investment planning, you get me, to be able to make active decision of how to utilize that land, you get me, for returns on investment. So this is critical. And also the height values. You need to be able to know if that area is a rocky area or if it's not. If it's a rocky area, you cannot plant on stone. So you cannot use that area. You get what I mean? Again, visual assessment. You want to see, you want to assess visually. Without visual assessment, you probably won't go very far. Unfortunately, so. So this also has its own backend database, right? So it changes color because you want to be able to classify. So you want to classify different areas, maybe by height. You get what I mean? Mostly by height or elevation. And these are the different file formats for raster. You have the TIFF, ASC, IMG, JPEG. All of them are accepted by your software, GIS software. But then again, each one of them still must have a projection. It is critical. You get me? Because just like your survey plan, which is raster, this is also a raster. So you have data, your tabular data types, which these are your tables. You get what I mean? In your GIS, you can combine this, you can join them together. So you can join two different values together. So for instance, you can join, so if you say, I want to see, I want to have one single file, right, of farms and fertilizer distribution to farmers. You get what I mean? So you have a table that has fertilizer distribution and the ID of each farmer. Then you have another data that has the boundary of the farmer and the ID of the farmer. In the GIS, you can join the two using the ID of the farmer, right? Because the data for the fertilizer distribution and how much fertilizer is being disbursed to this thing is in Excel, right? But it doesn't have any geographic variable. But you see the boundary has geographic variable in terms of location, right? And orientation. So how do you know which farmer has received what? Since the fertilizer distribution is in tabular format, you do a join. You can do a spatial join or you can do a table join. You do a join. So in that use the ID as the common area, because the table has farmer ID, the boundary has farmer ID. You now use that to join the two together. So when you now click on a farmer polygon or a farm polygon, it now gives you the information about the amount of fertilizer that's been disbursed to the farmer. These are some of the common tabular file formats as well. You have CSV, you have XLX, which is Microsoft Excel. You have DBF. QGIS cannot read Excel file formats, but it does CSV. You get what I mean? So if you save it as CSV, you'll be able to catch it. But ArcGIS does CSV, anything you push to it does it. But your data system must be clean. So then you have geodatabases. You remember the system you need to store, right? So you have the databases for storing the data, the geographic database. So They are different from your regular database. Your Excel worksheet is a database for storing numbers, for storing information, attributes, and stuff like that. But it doesn't have any geographical primitives. You need to combine it with similar data to be able to get the right information. But for GeoDatabase, you now have the two of them together as one, where you can now basically use it. But the disadvantage is it can only be opened by Esri software. Now, because all of this basically were created by Esri, it's actually a marketing tool, so that the moment I get you latched on onto my system, my file types and everything, right? You're gonna need me to be able to use other software to interpret what I have. So that means, you get me, I become like a major player in the market. You get what I mean? So it's a marketing gimmick, basically, and they were able to do this, through legal means, right? So there are other data formats. You have KML, which I'm familiar with in Google Maps. You have DWG, which some of you that have used AutoCAD before. You have CDF, which is scientific data. You have LiDAR, you have GPS units, you have JOSIN. Then you can export it to Adobe, KML. That is your Schaefer. You can export it to you can export it to JOSIN, JPEG, whatever you want, you can do the export. That is where the interoperability comes into play. Now, let's talk about the workflows. Yeah. Now, you can, when you look at satellite remote sensing, right, photogrammetry, statistical analysis, visual design, all of that. Again, you should be able to move them, from their traditional source, right, to be accepted in the GIS. So, for instance, a process imagery, can a process imagery as rasters or vectors, with enhancements, classifications, right, goes into the GIS, right? Raw imagery, you can use it for your base maps. You can process imagery as rasters or models. You get me, auto photos, DEMs, 3D models, right? Then statistical analysis, you can process the attribute tables for running analysis, regressions, predictions. Then you can generate maps for improved design aesthetics. You get what I mean? So essentially, you can process all of this together, as this model here. Here, right? So you have all of this all processed together, But for each layer, the process is different, right? That is what this slide is trying to explain to you. The process is different, so you just try to let you know, what can be done and what is achievable. And so this exercise is there, I mean, you can do this at your spare time. You can take a screenshot of this, so you can download your QGIS, and if you have ArcGIS, if you have your your Google Maps and all that, So download this data, right? And I'm sure your convener will be able to provide you sample CSV files, sample shape files, and all that you can play around with. So you'll be able to see all the things that we're talking about here. But it's imperative that you actually try your hands on this. You get what I mean, and you can see basically how this stuff basically works out. So in terms of the characteristics of spatial data, you have generalization. So the most detailed data available is not suitable for all purposes, and often manageable file size. The higher the resolution, the larger the file size. You get what I mean? So the higher the resolution, the more detail you get, right? The more detail you get from it, right? But the lower the resolution, the less detail you get from data. Sometimes there's generalization. You get what I mean? Where instead of you getting absolute information, you get something that is relative. You get what I mean? So it's not going to give you, oh, this is the exact place. It'll tell you that, yeah, it's happening around somewhere here. It's just to be able to give you. Then you now have abstraction, reducing data from its complete state. So for what is necessary for use and in presentation. So if I asked you what data symbology that you can see here, would you select for each of the following maps? say you want to use land use study of adjacent property, development map of the airport, or national map of airports. If you look at this now, A, right? A is like land use study. You get what I mean? So you use the satellite imagery to be able to show you what is going on. You get what I mean? So A and B, more or less, Then it now goes further to be able to give you more detail, So you extract data, in terms of the boundary of the airport. Because here, you don't know what the boundary of the airport here, unless you actually do this, because the boundary of the airport will extend up to here, But if you have like the plan, developmental map or development map of the airport, then you cannot see the boundary where the extent of the airport is. This is what is referred to as development map of the airport. Then you cannot go further to now, further divide or create more detail in terms of what is available on the airport. So depending on the solution or the problem that you're trying to solve, you get me, that is what will determine or say what level of detail is available. And also, when I was talking about spatial resolution and scale, the higher the detail, the more information you get from it. So if you look at these two pictures now, right, here you have higher spatial resolution, higher detail. You can see the streets, you can see features and stuff. Here you can't. This is lower resolution, you get me, or higher scale, you get what I mean? So depending on what you want to do, what level of information that you want to use. Let me give an example. We did a pre-investment assessment for 36,000 hectares greenfield for a client, for oil palm development. And for that, we had to acquire 70 centimeter satellite imagery, very high resolution. If we had done 3 meters or 5 meters, we won't be able to get as much information as we needed, you get me, to be able to identify or to be able to classify the land cover types. But with very high resolution, we're able to achieve that. You get what I mean? We're able to zoom in and see even the water, the rivers, how it's basically distributed and all that, So for different stuff, especially in agri, different scales or spatial resolution is required. In monitoring agricultural or crop health, normally, what is freely available, we use Sentinel-2 data, which is like 10 meters resolution, you get what I mean? So there's a huge level of generalization there, right? But if we're to use high resolution multispectral satellite imagery of like maybe less than 3 meters, we'll be able to see more, For 10-meter resolution, we cannot see row of crops. No, it's generalization. It just tells you, okay, this area is red. Why is red? I mean, what is there? We don't really know, you get me, because there's a high level of generalization. But if you have something of a higher spatial resolution, you get me, maybe less than 3 meters, you'll be able to see, there's not going to be generalization. You'll be able to see the row of crops. But the question is, the higher spatial resolution is way more expensive than the lower spatial resolution. That is why Sentinel is free. You get what I mean? And that is why when you want to purchase high resolution multispectral satellite imagery, they tell you, okay, it's $15 per square kilometers and stuff like that. You get me? It's not free, because it requires more resources for you to be able to generate data and put it together, which here, you don't really need much, to be able to get that done. Then you have the temporal resolution, which is timing. If you go to your Google Earth, right, if you open your Google Earth right now, and you go to where the tools are, right, there's a tool there that shows you historical imagery. It's like a clock, If you click on that, it will show you the dates of the historical imagery, so you can now see how that area has changed over time. You get what I mean? You can use that as well, which, as you can see here, 1977 to 2006 You can see clearly that they use Google Earth here. So with that, for stuff like maybe forest, canopy monitoring, stuff like that, you want to see how much of your forest reserves has been depleted. You can use that to see, but you need to upload the boundary of the forest reserves first as vector on the satellite image. I now drag the slider, and you now be able to see that, oh, everything was fine in 1984. I think in Ondo State, you get up to 1984. But from 1984 down to 2024, you now see the depletion of the forest reserve because of activities of farmers. Remember, I used that as an example at the opening in terms of traceability for cocoa farmers. You shouldn't plant in areas that are protected, because you are disrupting the biodiversity, and also you are reducing the amount of, you are increasing the amount of carbon emission in that area, because when you cut the trees, you understand? So all those are things that people look at, institutions look at, to ensure that, okay, you are not basically destroying the natural ecosystem. Because when you farm and you don't check them, what happens is you cut everything, you say bushmeat, you get me? That is biodiversity. You get what I mean, But in Nigeria, you know how it is. We kill, cut everything, we kill all the animals, put them out there, eat them and stuff like that. We're actually, disrupting, the natural ecosystem, which is not good. That is why foreign bodies that are responsible for regulating cocoa trade, they basically put that in mind that, hey, if you're farming in the forest reserves, you get what I mean, we may not buy from you. You get what I mean, Or if you're farming there and you're not actively repopulating, the forest, right, we may not buy from you. So that means you need to be able to provide evidence that, okay, you're actually planting new trees, and stuff like that. So, yeah. So, searching for spatial data, how do you source for this data? This stuff is actually, a lot of them are freely available on the internet. You get what I mean? So you can search the internet, say GIS data, or say, for instance, there are some websites that actually keep data on farms, infrastructure, and all that in Nigeria. One of them is Grid3. Grid, GRID 3. If you go to that site and you search any subnational level state, you'll be able to get information about different geospatial data available for different areas that you can download free of charge, to use as you wish. Other, but for specifics, obviously you have to collect the data yourself. So these are some of the, that you can use, that are global, So a lot of these actually collect data on Africa as well, So you can do your own independent search yourself. And yeah, so we look at metadata, right? So metadata is like description of the data. Typically, if I want to purchase data, I request for the metadata first. I want to know how it was collected, when it was collected, how was, the quality of the data, the coverage, and all that. Metadata provides that for you. When you are creating geospatial data, it is essential that you create metadata so that it basically lends credence to the data that you have. It's essential. You can actually create metadata. There are templates for that in ArcGIS Pro for those of us. So you can go to these websites, and check what is available, or you can just do a Google, you get me, sample geospatial metadata. It will give you loads and loads and loads. You get what I mean? So it's just for you to get your head around basically how metadata is organized. And so from beginning, we talked about the concept of the GIS as a system. We talked about how GIS models real life. We talked about, examples in terms of traceability. We use cocoa farmers as an example. We use, monitoring farms. We talked about the different data types, vector, raster. We talked about, the resolution in terms of spatial resolution, temporal resolution. We talked about, different file types, right? That accompany both raster and vector. For vector, we talked about the shapefile, then for raster, we talked about, the TIFF, ASC with JPEG, you get what I mean? We talked about KML, we talked about JSON, we talked about storage, the tables, for that company. So if we go back to the definition of GIS, we have, capture, store, manipulate, analyze, present. So all we've been talking about since is how we collect the data, sources of collecting data, how the data is, is how the file types is actually put together, the dynamics, of what it represents. I also use, survey maps, how you convert paper maps, to digital or your GIS. But now we talk about making green maps, presenting your information for anybody to be able to understand. You get what I mean? Making maps or great maps is an art. You need to be able to show something to someone that says, oh, this is what I'm talking about. So that the next question the person is going to ask you, like our clients, when we show them satellite imagery or land use classifications, the next question they ask us, okay, how much of this land can we use for farming first? So you have 14,000 hectares or 36,000 hectares, but you cannot say, oh, I have 36,000 hectares, really. You get what I mean? So when you are doing your economics of production, you cannot do it based on 36,000 hectares. Are you getting me? You have to do your land use classification first to be able to get insight that will not tell you that, oh, out of the 36,000 hectares, you get what I mean? You only have 22,000 hectares that is useful for cultivation, because the other ones have water bodies, they have rock art crops, they have communities, they have different stuff going on there, right? But areas where you can actually cultivate is 22,000 hectares. You now use 22,000 hectares in creating your economics of production or your financial model. You get me? For you to be able to get money. If you use 36,000 hectares, you're going to be running a risk of higher, liability on yourself. You get what I mean? Because the 22 minus 36 is that is 14,000 hectares. It's of no use for you. Are you getting me? So now you are not saddled with 14,000 hectares liability that you've created for yourself, which for that 40,000 hectares, the money that you collected for it, you are not getting anything from it. But you have to pay back. It doesn't make any sense. Are you getting me? It doesn't make any sense at all. That is how you make informed decisions. Remember when I said the key output of any GIS is a map, and the key outcome is planning. If somebody says, oh, we have a GIS, and there's no map that can show you that or that been derived from it, that is not a GIS. In different states in Nigeria, they have GIS. But the question is, how many maps have been generated from it for public use? You ask yourself. I'm sure some of you here, you don't even know the states that you're from. You don't even know if they have a GIS or not, because you've not seen any map. You've not seen anything that's come from it to be able to show you visual assessment of anything, either give you direction or show you what is going on. You get what I mean? You don't know. You get what I mean? And they say they have a GIS. The basic premise is mapping. Are you getting me? Map production, visual assessment. You get me? Presentation. So if there are no maps coming out, you get me? That is not a GIS. I don't know what it is that they spend their money on, but it's not a GIS. So moving forward, I use the example I just used is what typically happens in the agri sector, right? So before you start saying, oh, I want to cultivate 10 hectares of land. First, in that 10 hectares of land, how much of the 10 hectares is actually usable for cultivation? When you do your soil test and your land use mapping, or classification within your soil test, how much of that area is suitable, has high suitability, moderate suitability, low suitability for cassava, for maize, or for whatever you want to also soybean. You get what I mean? How much of that is usable for oil palm? How much of that is usable? If your map cannot show you that, you get me, then there's a problem. You are going into that investment blind. So that means you stand a high chance of losing a lot of money. Because if you are using soil that is good for oil palm to plant another crop, to plant cocoa or whatever it is, you get me, you're going to run the risk of losing money, because what is going to come out there is not going to be optimal. Are you getting me? So if you're talking to farmers, you need to be able to ask this sort of questions, right? To know, hey, what have you done? Really, smallholder farmers in Nigeria, they don't do that because cost. Most of the cost is actually, subsidized by government. As you can see, the case of the Ankobora scheme, basically that was deployed by the Central Bank of Nigeria. A lot of them subsidize for farmers. You get me? Your smallholder farmer that has 1 hectare doesn't have the financial muscle to do soil tests because he doesn't have money. You get what I mean? So he's just going to go there, do whatever. He doesn't have money also to pay for tech. Are you getting me? What he can probably do or pay for is information that will enable him to be able to get high yield. And that information is usually tied to finance. Are you bringing money or not? That is why you see that 80% of farmers in Nigeria that are smallholder farmers, you get me, they struggle in terms of low yield. You get what I mean? Low yield. They struggle unless you cluster them together and you provide them that level of capacity building and deploying this tech. You get me? Then you monitor them closely, to be able to generate maps, see how they're using the data. You get me? Especially in compliance with good agronomic practice, right? Then you'll not get anything from them. But because they're poor, you get what I mean? I'm farming 0.5 hectares, I'm farming 1 hectare, 2 hectares, 3 hectares. I'm not interested. I just want to make money, you get me, and take care of my family. You get what I mean? Now you're saying, oh, one tech, one drone, that you get me. I'm not even thinking about that, man. You get me, But if I have 100 hectares, I'm an investor. You get me? I want to get my money back, because for instance, if you're farming like 100 hectares of maize, for example, and you do the economics of production, or let's say for cassava, you do the economics of production, which probably comes to like 600,000 naira per hectare, multiply that by 100, that's 60 million naira. Are you getting me? It's somebody that is able to bring out 60 million naira. It's not poor. Are you getting me? But he wants to get 30 million naira from that 60 million naira, So how do you make sure he gets 30 million naira, profit from that 60 million naira investment? What do you do, right? You have to do your soil mapping, land use classification. You have to do all of that first to be able to say, hey, this land is very good. How do you present that? You use a map to present that. You get what I mean? So that they can see the different areas of the land that's actually good for planting. And you can, you can divide it also into different, grids and stuff like that. You get what I mean? So essentially, making great maps, has to do with communication. You want to communicate information. You want to present information in a way that is easily understood, right? For reference, it is easily understood. If it's not easily understood and it is not clear, then it is not well communicated. So that means you've not made a great map. Again, like I said, when you make a map, give it to maybe your nephew, your niece, let them look at it. They start asking you questions. Children love colors. Uncle, why is this? Or auntie, why is this place red? Why is this place yellow? Why is this place green? You get what I mean? Those are the sort of questions, they ask you. These are the same questions your clients will probably ask you as well. You get what I mean? So now the 3 key questions, right? Like I explained using the farmers. Who wants the map? Experts. In terms of investors, it has to be detailed. I use the example of 70 cm. Are you getting me? Compared to using 10 meters. If I use 10 meters, there's going to be a lot of generalization. I'll be lying to them because they will be losing money. instead of the stuff to show them that, hey, guy, you have only 22,000 hectares, you get me? You know, it probably showed them that the entire 36,000 hectares is good for production, which is wrong, right? Where will it be seen? Is it going to be seen by in a boardroom? You know, do you want to use a web map? We use web maps. Most of the distance we use web maps because we can share the link. You get what I mean? You know, so the client can call me and be like, that area, man, I can see that there's a huge rock. Like for instance, the ones that we did for our client in Ondo State, 14,000 hectares. You know, it's actually 36,000 hectares. But you know, split into 22 and 14. You know, the 14,000 hectares has over 1,500 hectares, you know, of rock. So that means out of 14,000, it's already caught 1,500. At the end of the day, when we did the land use, what did we get? We got about 11,000 hectares, you know, usable for agriculture. You understand? Or for oil palm production. What's its purpose? You get me? Is it to show variable through time series? Like you want to show the health of the crop throughout the production period, from planting to harvest, right? You want to show how much the health, you get me, you know, as you know, maybe has improved or declined, you get me, especially when you apply fertilizer, right? But you need to do that in relationship with good agronomic practice. You cannot do it alone. You know, there's a common misconception that, oh, well, you get me, precision agriculture, use this, you get me, it tells you where fertilizer is needed, you get me. When you are applying fertilizer, you apply fertilizer per hectare. You apply fertilizer to every plant on the farm. You get what I mean? You know, because you've already done your soil test and it says this place is usable for this crop. You apply fertilizer to everywhere. Are you getting what I'm saying? You know, not that you put somewhere, you don't put somewhere. I mean, if you are doing dry season farming, you know what I'm talking about. You're going to suffer. You get me? Because you're going to lose. We have a farm that we're operating right now that we're going to have to, you know, which is standard for dry season cassava production. You know, we have to replant some areas. So we've done analysis of each row, how many we have to replant. That will now inform us how much we need to buy the cassava stems and to plant. Are you getting me? You know, for this rainy season. You get what I mean? You know, show change over time. Also, change detection ties to your time series. As you're looking over time, you know, there are changes being made. If we use the example of your crop monitoring platforms and stuff like that, you know, you'll be able to see the difference between last week and this week. You get me? It detects the change. You get what I mean? And how does it detect the change? Because you are using multispectral data, right? Incident light from the sun, when it hits a leaf, right, of any crop, it catalyzes energy production, which is through photosynthesis. The photosynthesis, right, during that period, you know, when the light, you know, light refracts and it reflects. So when it touches the leaf, you get me, as RGB, it now reflects back into the atmosphere as near infrared and red. Are you getting me? The satellite images now capture the variability of the near infrared and red. So low near infrared and red basically means the stuff is brown. It's not generating as much energy. It's a weak plant. High means it's you know, it's healthy. You get what I mean? You know, we want it high all the time, not low. You understand? So when the leaf is brown, I remember it's the leaf that's the key vector, right, that generates the energy. You get me? Not the stem. The stem basically passes the stuff through, down is what connects the leaf to the soil, you know, to take nutrients back to the leaf, right? So once the leaf is brown, then it's going to affect every other thing. You understand what I'm saying? It's going to be too weak to be able to generate energy that it needs to grow. So your satellite imagery will be able to show you that variability over time in terms of change detection. So you see some areas are red, some areas are orange, some areas are yellow, some areas are green. You get me? The areas you now focus on is red, yellow, and orange. The green areas, you still focus on them because weed is also green. Are you getting me? Weed is also green. If you are using high resolution imagery, sort of drone imagery or, you know, satellite imagery, very high resolution, then you'll be able to see the weed. Are you getting? But you have to look at the cost. Is your client willing to pay that money for that? You get me, Because in the economics of production, the clients or you have already costed for labor that will clear the weed or that will show, stuff like that. So really, you may not, you understand what I'm saying? We have to think of the cost as well, So it's not something that is pretty straightforward like that, So again, combining multiple variables into index to pick best was, sustainability, risk, vulnerability mapping, site selection. So I explained that earlier using examples of flooding, flood vulnerability analysis assessment. I want to see the households, because we're using for flood water, you need to use your digital elevation model, which can derive from your drone flight. I want to see households that will be affected by flood. You get me? During wet season. And I also explain how it connects from with Ministry of Health, Ministry of Works, how everything basically work together. So you want to do that site selection. I want to select sites best suitable for avocado production, for maize production. You get me? How do you do that? You get what I mean? You have to go through the analysis to be able to identify different areas. I'll give you an example. We did a project for Niger State government, in site suitability assessment. So we mapped all the agricultural lands, everything, basically anything that's got to do with agriculture, infrastructure inclusive. We mapped everything. We put it online. Niger State is the only state in Nigeria that actually has that at the moment. You get what I mean? And I think it was displayed the last time, His Excellency the President was in Niger, So you look at that. Now, Niger State knows out of the 7.8 million arable farmland, they know what is actually available. Are you getting me? That is minus settlements, minus forest reserves, minus game reserves, minus water bodies, minus hills, because those hills and high elevation areas also fall within the 7.8 million hectares. You get what I mean? So these are the sort of things that you want to use. For instance, Ekiti State. Ekiti State has 2.9 million hectares of arable farmland currently under cultivation. Are you getting me? So when you want to do stuff, you need to look at, okay, hey, what is the best site that I need to be able to do this? So you have to start selecting. You get me? You need to start isolating factors, isolating features, you get me? That will not give you, okay, after you removed forest reserve, settlements, areas under, all of these things, this is what is left. You get me? For this. But then again, you need to look at the condition or the parameters that actually favor that crop. Say avocados, you need areas, you get me, with kind of slope, you need areas, with adequate water, you need, all those information. Now, once you have those parameters, how do you identify them on the map? This is why we do the web map, so that you can make queries. You get what I mean, and also extract the areas available. The map design process, you need to assemble the data. So you need to know how to assemble the data. If you look at that first picture, that you have different layers together, assemble it, you get what I mean? So okay, look, hey, what do I want to be as the operational data? The operational data could be your customers, it could be your farmers, you get me, those are operational data. Those are data sets that you collect on the field that defines the rest. You get what I mean, So the rest being your fundamental data, that is your satellite imagery, your digital elevation model, your road network, your settlements, all of that, you get me? That is your fundamental data. So when you now put the operational data on it, you can now see, oh, this farmer falls within forest reserve. If you don't include forest reserve, how would you know that the farmer falls into forest reserve? You get what I mean? So you put everything. Then symbolization. The farmers that fall into forest reserve, do you want to put them as red or yellow? You get me? The farmers that fall within the free area, do you want to put them as green? Are you getting me? You do that, then you put your legend, your north arrow, scale bar, and labels. A good map has these 5. Your title must have a title, that says this is what this map is all about. The legend tells you, oh, this yellow is this red is for farmers that fall within forest reserve. This yellow is for this green is for farmers that fall within free area. The north arrow, you cannot have a map without a north arrow or a scale bar and labels. Are you getting me? You know, so these 5 must always be on your map, you know, and I will implore you that you should go ahead and create sample maps. You get me? You know, knock yourself out, you know, make different maps. You get what I mean? Don't visualize. It doesn't matter what, it doesn't really have to be with live data. Your confidence will be able to supply you with, you know, data that you can use. Use that, try that, you get what I mean, and say, all these vector symbolization, a number of them are actually within the ArcGIS Pro or QGIS and all that, you get what I mean, you know. So even your Google Earth, you know, you can use that and basically plug it in to be able to represent the information that, you know, you want to present. Then raster symbolization, how you symbolize your vector, right? You know, so this is vector symbolization, you know, because you have points, you have lines, you have all of that. But for raster, it's different, you know. So you can stretch, you know, basically instead of the color, right, or values, you can have discrete, you know, data, you know, where basically you can cluster them together. You can classify them based on certain values and group them together. You can have unique values. You can have vector field, you know, depending on what is available. But typically, if you right click on your raster in ArcGIS Pro or QGIS, the property pops up and the display, you know, as symbolization it pops up as well. So you cannot select the one that you want, you know, based on the kind of information that you need, especially color, how would I call it? You know, color, like color bands, or, you know, I know bands is not the right word. Yeah, it will cut me. But then again, if you're colorblind, you know, you have to be careful. You get what I mean? You know, some people are colorblind, but, you know, so obviously you have to know what, you know, you have to be able to use. So choosing color tips. So you have qualitative categories. Qualitative, so you have discrete classes. You can see the discrete classes, you know, different colors, each one. Then you have quantitative numbers, it's sequential, you know, low to high, diverging, negative to positive. You get what I mean? You know, so from low to high, you can say, okay, in terms of height values, you get me? Pink is low area, red is high area. Are you getting me? You know, in terms of qualitative, you get me? You know, farmers in forest reserves are green. I mean red. Farmers in free area are green. You understand? You know, again, if you are colorblind, that's a different ball game. You know, yeah. So that happens for a lot of people, especially in GIS. You know, so you can see qualitative color example. You know, internet users per 100 people. You get me? So this is the qualitative. So you can see in Nigeria is orange. We have 15 to 36.6 per 100 people. You get what I mean? You know, so it's very distinct. Sequential color sample, internet users per 100 people. You get me? You know, you can see the different colors. You can see how it's graded. Then diverging color, same here. You know, so you use color basically that makes sense, that enables you to be able to communicate what you're talking about. Then you have commonly used map types. You have chloropeth, sorry, you know, the number of classes, you know. So when you are doing classification, you can say, okay, I want 7 classes, you know, and the map will break it down into basically these areas. The classification methods, you have equal interval, you have contour, natural breaks, manual, you get what I mean, you know. So you can see how it's presented here, you know. So the second exercise, which also I will encourage you to try out, is to learn how to prepare a sample map, right? And how to basically symbolize the map, you know, just something very basic. Again, is to get you used to basically how to present your information, you know. So from data collection to storage to analysis to presentation, you know, for you to be able to make sense of this thing. Then map layout. Your ArcGIS has map layouts, that you can select from different types. You get what I mean? That you can select from. You can design it with your own stuff. You can put your logo, you can put your titles, information, and all that in there. So, like I said, try to navigate the software interface. Like I said, download QGIS, play around with it. Your conveners will provide you sample data, including base maps that you can play around with. Play around with the attribute data, do the symbolization, and basically present the map for you to be able to make sense. So I'm going to stop there at this point. I hope you've been able to learn one or two things, especially in terms of agriculture. But before I get off finally, I'm going to stop sharing. Then I want to put up the web maps like I promised, so you can see what I'm talking about. So give me a second. Any questions that you have, please don't hesitate to put it on the chat, please.
Yes. Yes, sir.
So I'm just gonna give me 1 second, please. I'm launching the.
No problem, sir.
I'm launching the web maps. One second, please. Let me I'm trying to get, there's a particular map that I'm trying to get for you. So you can see how the high resolution satellite imagery stuff basically works. Any questions so far, though? Guys, you can't tell me you don't have any questions, or?
Yeah, we have some questions here.
Yeah, fire. No.
Okay. I was hoping that you would share the.
Yeah, no, carry on.
Okay, so there's a question from Precious. She's asking, can Google Earth Engine be used for data acquisition? And if yes, what kind of data and the quality?
Sorry, can what?
Can you see the screen, sir? Can you see the screen?
Oh, sorry.
If you look at the screen.
Okay. Yeah. Can Google Earth Engine be used for data acquisition? If yes, what type of data and the quality? So Google Earth Engine has different data types that you can actually use. So you have the free ones and you have the paid ones, and you can use it. I believe you can use it for raster. You can use it for vector data as well. Google Earth Engine is actually very good for data analysis. So it's like any other thing, is geographic. Are you getting me? But you'll be able to import external data. You get what I mean? That is not geographic into it for you to be able to make sense. You get what I mean? But then again, best thing you can do is for you to go to Google Earth Engine. You get what I'm saying? Which you can type in your browser right now. You get what I mean? Create an account and start playing around with it. Whatever I say is not enough. Are you getting me? If you don't try it out, let me be honest with you. No matter whatever I tell you, if you don't try it out, you won't understand. You get what I mean? So you need to get into it, so that you can basically make sense of the data, yeah, or sorry, of the software. So just go there, right? And give it a shot. And that was why I said, you need to download the data and be able to, so that you're able to see what is available on the software. Because just hearing an instructor giving you that kind of information is not enough. You have to play around with it yourself to be able to see what actually is going on, with the with that data. So I will encourage you to please do that, for you to be able to have a better understanding. So if you now look at it and you now have issues, then you can now come back to us to now say, hey, why this, why that? You get what I mean? Yeah, that's the best thing. You can only understand through trying, and you can only be good at it through trying. So I'm going to let me share my screen.
Okay.
Okay. Femi, I want to ask, can I, instead of me stopping and sharing for this thing, can I just be clicking on each of the tabs and it's going to be showing? Yeah. Okay. No, don't worry about it.
Okay.
Don't worry. Can you see my screen, everyone? So as you can see,
yes.
Right? Yeah. So here you have, come on. Okay. So here you have, this is the land that I was talking about. So you have the soil sample point here. You click on it, it gives you information about that point in terms of, the soil sample. Oh, sorry. And because the first thing that we had to do was to acquire the satellite image and do the land use classification. While that was being ongoing, we're doing like the soil mapping. So if we now go to, let's go to, okay, so let me, until, okay, let me turn off this once. And so you can see the satellite imagery now, right? You can see how detailed it is. You understand? You can even see the crops, if you look at this thing, you can see the water sources. You understand? If you use something of a lower resolution, you'll not be able to see this level of detail. Are you getting me? You'll not be able to see. So if I now go back and I say, you get me, aha, you can see this is the land use map. You can see that it followed the water source. Are you getting me? So out of this land use map now, we're now able to get how much of the land is usable. Are you getting me? For production? And here, this is 22,000 hectares. So let's go back. This is actually for an investment of $350 million, right? So let's go back here, this area. So if yeah. So if you look at this side, you can see rock outcrop here. Are you getting me? You can see rock outcrop here. So let me now show you guys something. Let me stop sharing, so you can see. Okay. Sorry, 1 second. Let me just share again. Mhm. Mhm. You can see. So this is the land use classification from the satellite imagery. You can see this area now. Yeah. If you look at the built up area, it says it's 95 hectares, 0.68%. Farmland, fallow land, 1,108% hectares. Rock outcrop, 1,075 hectares. Are you getting me? Forest is 11,824. Water body, 39 hectares. The total is 14,000 hectares. Are you getting me? So you can see that the forest makes up the largest, but the proportion of this thing. And you can see here, the what's it called? The settlements. You understand? Now, do you know why we have to do all of this? Because if you are doing something of this scale, you're going to compensate the people there that are already producing there. Are you getting me? How do you know who is who or where they are, where they are? Are you getting me? This is where this level of assessment comes into play. So you can see how vector was derived from raster. Are you getting me? So that's it. Now let me quickly show you. I know you must be a bit tired, but let me just show you the time series. This time series stuff quickly before we go. I'll show you one more after this time series. Then I will not take other questions. But if you have any other questions now, please don't hesitate to provide that. So you can see here. So you can see here, you can see the dates. You get me, you can see Sentinel-2, So for the dates, it's giving you different colors. Now you see that all these times is red because it's dry season. Are you getting me? It's dry season because the general vegetation is dry. Are you getting me? So the near infrared and red is very low. You understand what I'm saying? You can see now it's becoming yellow. Small rain is falling. Are you getting me? So as you are moving forward, you get me, as it's raining more, the colors will be changing. You change to green, you get me, you change to light, you get me, or light green and stuff like that. Because again, take into cognizance the resolution of the data. Yeah, right. It's low resolution. So there's a lot of generalization. It's free. So I can tell the farmer that, okay, do you know what? I charge you maybe 500 naira per hectare. But if I'm using high resolution or I'm carrying drone and pay for logistics, there's high distance. You get me? Which farmer is going to pay for this thing per hectare? Are you getting me? I can't charge the farmer 500 naira per hectare now. I get what I'm saying. So if I say 1 hectare, right? I get that it says 1 hectare. Is it 500 naira that it took me to move the drone and everything there? No. Are you getting me? So, it is not just the knowledge, the technical knowledge, but if you want to be financially independent, you need to understand the concept of the money bit of it as well. Because at every stage you're spending money, and your clients do want to spend money. You get me? So what I pursue is it, you need to be able to understand those concepts. You get what I mean? And that is why I use the example of smallholder farmers. You get me? Most of this thing is subsidized for them. Are you getting me? So let me show you the last one, which is the disaster management. We have a lot, different ones that we do. Everything we put on the web, So this is the disaster management, right? These areas are flood flashpoints, these red areas, and we did a buffer. Remember in the training, we did buffer. We did a buffer of 500 meters around each one. You get me, So we can see that this is the drone flight. You get me? This colorful stuff, right, is from the DTM, generated from the drone flight to identify areas that are vulnerable to flooding. You get me? The red lines are the contour lines. You get what I mean, It's pretty very high resolution, And yeah, so here is in Akure, is just to show the Ministry of Environment in Akure, and the Ondo State Environmental Protection Agency, that if you want to reduce collateral damage during the rainy season, right, regarding flooding, this is what you should do, so that you can improve on communication and planning, you get me, for the households or businesses around those areas. But then again, when we now went to the field, we now discovered that the gutter, right, or drainage was blocked with pure water, plastic bottles, and everything. You get me? Who is going to clear that? It's Ministry of Works. Are you getting me? If when you clear that, are you getting me? Who's going to benefit from it? The households, and also the Ministry of Health will be able to provide some level of monitoring in terms of incidence of malaria and all that. You get me? All of these things, they cost money, because when it happens, you need money to treat yourself. When flood happens, government has to provide money for palliatives. You get what I mean? I mean, why don't you be more proactive instead of being reactive? You get me? And we now went further that, look, hey, you need to embed this in your OSEPA law. Are you getting me? The use of drone technology and geospatial data for decision making and for monitoring and evaluation. You understand? So yeah, so this is what I spoke about last. In terms of what's it called? Vulnerability, sustainability, and all that. So yeah, so that's it basically. And lastly, I'd like to say, geospatial data, like I mentioned at the opening statement, is very key for national development. We cannot discount that. Are you getting me? The more we start seeing the role of geospatial data playing in national development, monitoring distribution of inputs to farmers, traceability, and all that, you get me, the better we have a good understanding of how to manage our resources, how to manage our land, how to manage the resources under the land and over the land. You get what I mean? And how to manage the land in itself, ownership of the land. That is the earth. Are you getting me? You cannot manage the earth without managing the land. It's the land that constitutes the earth. You get what I mean? It is the land that now goes further in terms of geography to affect investment promotion, right? Because, and I'll tell you why. Land is a factor of production, one of the 4 factors of production, right? Now let's take that also into the ease of doing business, right? Property registration in terms of land registration is one of the 4 pillars of ease of doing business, and in terms of business enabling environment. So if you don't manage your land, and you don't have geographic repository or what is under the land, what is above the land, and the land in itself, you get me? You probably won't get anywhere. That is why we have key issues in Nigeria, to be honest with you. Then let's take that to agricultural production. If you are not able to know what soil exists where, what water exists where, in terms of perennial sources or non-perennial sources, in terms of floodplains and all of that, how would you be able to attract large-scale agricultural investment to say, okay, produce here? Do you realize that there was a time in Kebbi State, if you Google Dominion farms, just type Dominion farms in Google, these guys, after spending millions of dollars, it was threat life that chased them out of Nigeria, because the government has at that time allocated 30,000 hectares of fertile soil, to a company. How can you allocate 30,000 hectares? Are you getting me? So basically, communities already farming there and everything, they were affected. And obviously, you get me, it destroys the investment. You understand what I'm saying? If you're making investment, there has to be social cohesion. You get what I mean? There has to be social stability. You get what I mean? You don't want to bring investment that will start killing the people or poisoning their water. Are you getting me? That was why the World Bank developed a framework called FRELIA. You get me? It's framework for responsible and inclusive land management. Are you get what I'm saying? That basically defines the relationship between investor and the communities that own the land. You get what I mean? So we cannot discount the our integral land geography, GIS, geospatial data, which is used to create a balance between economic, environmental, and social capital. Are you getting me? We cannot distance in economic development and self-reliance. You get what I mean? So thank you very much for your time. Thank you for listening. And if you got any questions or anything, you can please put it on the chat.
Thank you so much, Mr. Dewale. I mean, that was actually practical and enlightening. We've actually been taking some classes on, I mean, this should be our third or fourth class, particularly on the topic geospatial, around geospatial, and everyone with different perspective and communication. You've actually brought this. It's simple in giving us a basic introduction to around GIS, and you've also brought to us the application and the practicability of the information or the insight that we can actually gain through GIS and leveraging geospatial technologies. The applications are very important, how we can actually leverage them beyond the technicality, how we can actually turn them into decision-making tools by ourselves, with the government and other stakeholders. And I believe that those our students are, we're talking about precision agriculture, digital agriculture. How can we actually leverage this towards development of the agricultural industry in a broad sense? Thank you so much for sharing your time. I think we have some good comments here for you. Mubarak Adeniran says, thank you for the wonderful presentation. Yeah, couple of them. Yeah, I think I noted this question out. How can we integrate drone imagery into GIS platform for for advanced analysis? Yes, talking about resolution and all that.
I showed okay, for this, let me share my screen again to show you the yeah. So let me so yeah, let me share my screen again. Can you see this is drone imagery at the bottom here? Are you getting me? So this is for flood disaster vulnerability assessment. Are you getting me? Vulnerability. Who are the people that are vulnerable, that will be vulnerable to flooding? Are you getting what I'm saying? For you to be able to know those areas, you need to do analysis, because when you fly the drone, you get two types of data, right? You have the area orthophoto, which is this colorful one. Then you now have your digital terrain model, okay, which is this other colorful one at the bottom. Yeah. Now, this basically shows you what exists there. You get what I mean in terms of visual, capture. This colorful one is where the actual insight comes from in terms of vulnerability. So this is what we did. What we did on here is what we call slope. To be able to identify areas that will be vulnerable to flooding. You get what I mean? So if I go here and I uncheck all of this, you see these areas captured in red. Are you getting me? These are the areas that will be affected by flood. Are you getting me? So now the next question for me is, are these commercial buildings or are they residential households? You get me? Who is under what community are they? You understand? Who can we speak to? You get me? I'm talking to them that, hey, you guys get prepared. You are likely to experience flood during this rainy season. You understand what I'm saying? So that's basically it. So when you do your data, you can actually upload it to your GIS because it accepts it. It comes in the data that's acceptable, either TIFF, either JPEG, or either ASC. Then the advanced analysis is where you now start doing your spatial analysis. You get what I mean? Depending on what your objective are, is different. For agriculture, for flood, for I don't know, whatever you want to do. Is it locating towers, or whatever one you want to do? So you need to first, and I mentioned that at the beginning, first determine, have a vision. What do you want to achieve with this? Are you getting me? But any data that is generated goes into the No, that one's no question. You know.
Okay. All right. All right. Thank you so much for answering that question. Let me check again. Um, so, if I would actually ask for the sake of our students, uh, as as a professional with years of experience, what would you actually advise uh, and a young fellow who has agricultural background and who is actually interested in leveraging GIS uh, towards career growth and to deliver professional values? How can they begin to learn and also sustain their interest in this technical field?
That's a really good question. Our youth, some of our youth are not ready to, they are afraid of several things. Yeah, they're afraid.
Okay.
If you want to learn, you cannot be afraid. You know,
Mm.
we're afraid of death, we're afraid of being attacked. If you want to learn, agriculture is not done in the urban area, you know, it's done in the bush. That is first. So hold that one first. Are you getting me? For me, as a professional, I worked in Iraq, I worked in jungles in Liberia. You get what I mean? I worked in Ghana, everywhere. You get me? As I've been to those areas, I've been to St. Lucia. You get me? Holiday zones. I've been to, you get me? Worked in the UK for. Yeah, that's the thing. You know. So the experience that I had in this thing, you know, Iraq, you wake up, gunshots, you know, different stuff. You get what I mean? You know, you feel homesick. Are you getting me? But I got
Yeah.
an experience. Coming to Nigeria, I got into agriculture. You get me? The first thing that you can't go there, that do this thing. I went there. I slept there. I'm not dead. I'm the one speaking to you today. It's more competitive for me as a business because where I can go, a whole lot cannot go there. They can't even think about it. Are you getting me? So they recruit me to go there, which is not a big deal. Are you getting me? We sleep on the farms. Now, for you to learn, it is not desk. I kid you not. Any agri-tech company that is doing desk, you get me? Trust me, man. They are living on grants. Are you getting me? If you cannot measure with production, actual production, and be on the field, monitor what is going on, how you get me to get the ideas, then you know you're going to run into trouble. I would advise that you intern with a company that actually does this. You get what I mean? You know, either Flying Farmer, either Agro Exchange, Nigerian Flying Labs. Intern with them. Go to the field with them. Offer. We don't really need. I mean, like Agro Exchange, Nigerian Flying. We pay our interns. You get me? We retain them. Are you getting me? Give them the tools that they need. You get what I mean? Depending on your performance, you can only learn that if you work with people that have been on the scene. You align with them, you learn from their mistakes, right? And from your own mistakes as well. So if I tell you that, oh, you download this software, no. I'm basically telling you, are not going to go anywhere. It's not a desk stuff, it's a field stuff. Because the actual place you're going to use it, the actual beneficiaries are on the field, the farmers. You understand? So you have to be there, learning, watching, understanding this, understanding that before, so that your expectations are better managed within a scope of reality. Are you getting me? You know, yeah. Don't look, we can develop this software. You've not been to the farm. You've not even done farming before. But I can develop this software, this one. Are you solving a real problem or you are bringing a solution that is looking for a problem? Are you getting me? Yeah. So you need to consider all of those things. For us, everything that we're doing right now is primary production or processing. Are you getting me? That is where we now embed our technology into it. You understand what I mean? You know, nobody is going to pay for your tech because your tech has not really proved to me that you can double my ROI. So why would I pay for something that I'm not even trying to hear. It's not giving me anything. So the first thing is I'm going to pay you for you to produce for me. Then while you're producing for me, you cannot include your tech to say, boss, I cannot use this tech as support service, right, to secure your ROI. That's the sense of it. You know what I mean? That goes into your economics of production. Are you getting me? Yeah. So with that, it's a lot easier for you. You get what I mean? You know. Now everybody's trying to hedge against inflation. Are you getting me? Agri-tech in itself there's no software or whatever data that is going to increase your yield. Don't let anybody fool you. I kid you not. It is the actual practice on the field that is going to increase your yield. Because if you
Yeah.
choose the wrong seed, you are not complying with good agro practice and stuff like that. How are you going to get good yield? You
Mhm.
can do as much tech as you want, but you're not going to get a good yield. Are you getting me? The whole sense of doing all of these things is for you to increase your yield and increase your income. So I would say align yourself with companies and offer your services to companies that are actually doing this. You get me? If they pay you fine, if they don't pay you fine. You're just starting out. You cannot become big just like that. You get me? You need to
Mm.
contribute. I need to learn. You get me? So that as you're offering value, or improving in terms of value or offering your value, you get what I mean? You'll be getting bigger and you'll be able to deliver better this thing for yourself. You get what I mean? So
Okay.
that's little while advice.
Yeah, I mean that was actually uh, an advice from a mentor. I mean, straight from experience, and
Mhm.
that is what we actually learn on the field. I
Yeah,
mean, learn from experience,
yeah,
particularly,
yeah, yeah, yeah.
and well, I think that is actually an add-on. So, just to actually reiterate my question, in terms of the technical expertise,
Yeah.
um, it is important to actually go to the field. But before we go to the field, many of these are students who are actually young and enthusiastic about what the power of digital innovation can actually do in agriculture to bring, so how can, in this technical environment, GIS, how can they
Mhm.
actually learn? It takes hard work. And, yeah. So,
Of
what will
course.
you actually advise them, to be able to use this tech, learn, develop
Yeah.
their capacity on the technical side, then they can be able to then transfer on the field. That process
Yeah.
before going to the field will be
Again,
important.
it's still going back to what I said. You have to work, you get me? You have to align yourself with guys that are already doing it. So because that is where you'll be able to learn the technical stuff. You get me? You can take courses online. You can take the massive open online courses from Esri, MOOC, MOOC. You can take all of those to be able to brush up your technical expertise. Yeah. Download the free software, QGIS, go online, YouTube, learn about about how to use these things. You get what I mean? Download sample data, speak to your combiners, or form a WhatsApp group. You get what I mean? Where you guys can actively discuss all of this. But most importantly, in terms of technical expertise, you can do that. But in terms of application, you have to align yourself with those that are already doing it. You get what I mean? So that you can see how it's been applied, the real situation, how it's being used to solve problems. You get what I mean? You don't want to spend your time learning stuff something that is going to be of no use to you. If you want it to be of use to you, you need to align yourself with those that are already doing it. You get what I mean? So you can see how they're doing it, and how you can offer your expertise that you've learned, and also to learn a lot more. So that's what our advice.
Hello.
Yeah.
Okay.
Hi, Joseph. I can hear you. I can hear you. No, I can't hear you now. You're muted.
Sorry. Hello. Okay, sir. Thank you very much for answering that question and giving us insight from your perspective. They are very top notch. So let me check. If you have any other question, I think you actually give us a passing word. Okay. someone just said this that it's value 100% your presentation. Okay, so just positive feedback. Yeah, basically. Okay, all right. I think these are the comments you have from our participant. Basically, thank you very much. It has really been an insightful section with you. I learned a lot also from use of data, GIS, or Earth observation softwares to
Yeah.
actually gather data, either raster data or vector data. So I really just don't know. I think we've come to the end of the presentations. So it's really okay. Mr. Femi is back.
Yeah, thank you very much for having me.
Yeah, thank you so much for sharing value with us this afternoon, sir. So,
Yeah.
I mean, if you would like to actually hear uh, the final words on, on this presentation or section as we wrap it up, thank you so much.
Sorry, I didn't get that. You like to?
Your final words of advice, commendation, heads up to our students at Education Field Academy on this section.
Okay. My final word is you need to keep at it. Because one, consider the fact that we're training you. These are career path, and we made something out of it. That means you too, you can make something out of it. You can even be better than us. You get what I mean? We cannot be at the top all the time. However, you have to keep at it. You need to keep learning because we too will keep learning. And I mentioned earlier that look, I do not have the monopoly of knowledge. I want to learn from you as well. You get what I mean? So you have to keep learning. The moment you stop learning, everything stops. Everything stops completely. And that is what leads to failure. You get me? So when you keep learning, you keep getting more information. Learning could be practical, it could be theory. But whatever it is, you need to keep learning, and you can always reach out to any one of us, for information, for advice, or for mentorship regarding this area. You also have to bear in mind that agriculture can be a bit daunting, when it comes to agriculture. But the moment you get into it, you get hooked. It's like a drug. You get hooked massively. You don't want to do anything but to go to the farm. You get what I mean? So you have to do that. You get what I mean? Because let's look at it this way: agriculture is a no-brainer. We have 213 million people, population of Nigeria, that are ready demand for food. Are you getting me? And we complain about food insecurity. Who are we fooling? Are you getting me? We don't have to advertise food. You get me? You have to eat. I can decide that I'll buy this shirt next week, but I cannot decide that I will eat next week. That from today until next week, I'm going to start. No, you will die. You have to eat now. So agriculture is a good area to be, but it has its own peculiarities and dynamics, which you need to learn in practice, right? But like I said, you have to keep at it. You need to keep talking to those that have been ahead of you to learn from them so that you can always go double back, and apply whatever you've learned. You get me, for mentorship and stuff like that, Yeah. So Mr. Femi knows the programs that we run for mentorship and all those kind of things. It's called the African Alliance for Food Security and Agribusiness. You can take advantage of all of this. You can take advantage of the Precision Field Academy. You can take advantage of all of you're in there now. You have access to all of this. Take advantage of it, so that you too, you can grow. You get what I mean? Over time, and you'll be able to contribute your own unique insight, your own unique perspective, to all of these things. You get what I mean? That is very important, So I wish you guys all the best.
Thank you so much, sir. We do appreciate. Thank you for those words of wisdom. So, guys, some of our students are actually asking, are you on LinkedIn? We would like to connect with you. Are you on LinkedIn? We'd like to connect with you. So please check out his name on LinkedIn. That's simple.
Well, let me I think I can put my LinkedIn. 1 second. Let me just quickly see if I can put my link. Okay. Yeah. Got it. So I put it in the chat.
Yeah, I'm just copying that to get on the. That was people's. Okay, so you can find it on the screen. You can actually find it on the screen, or type in search for Adewale Adegoke on LinkedIn. I believe you'll be able to get to connect with him. And yeah, this is actually one of our objectives, to actually connect you with global leaders and professionals, leading professionals that can actually guide you and hold your hands, with their experience, their connection and network. So thank you so much, Emmanuel Adiola, for actually requesting for that, and also for joining me. Thank you so much, guys. So we will be ending the stream now, and see you tomorrow. Yeah, thank you so much.
All right. Take care. Thank you, everyone.